Good morning, friends. We are really going for the third important part of the physical world. In the first part, we have seen there is a war between the mankind and the nature. By means of properly using the scientific technique, scientific method, man can unfold the pattern of nature. So, what is meant by science? Science is nothing but the knowledge or the understanding of nature. Second, very important things, we have learned about up to 16th century, the facts about the nature was called philosophy because it was not proved in the experiment, in the laboratory. In 19th century onwards, it was really called as a science. So science is the 19th and 20th century evolved one. In science, the facts and all other principles or whatever may be the science they call it, all that are subject to verification. Whenever anyone found it is false, it is automatically be valid. So, a law which can be verified by hundreds of experiments, but a single experiment that can disqualify the particular law by means of its validity. So, science is a ever dynamic one. Next one, science really applied in universe in the three domains. The domains are called macro, meso, micro. Next, what will be the range of the domain? The range of the domain is very extreme. It ranges from atom to universe. So length, mass, time has got the biggest range. So science really applied in three domains and in all the ranges. In all the ranges, in all the domains, a simple scientific fact, law, called Newton's law of gravitation, let me suppose. A simple law which was derived from a falling apple from a tree by a person called Newton is applicable to everywhere. That is the beauty of physics, that is the beauty of science. The excitement of physics is nature's so many patterns can be derived into a simple law. The simple law is applicable in all the world. Now we are moving on to technology. What is science? Science is nothing but the knowledge of nature. What is technology? Application of science. What is production? If mankind approves the technology, then we are going for industry. Now, let us get into the third part of it. Dear friends, we are really going to study the relationship between nature, science, technology, and the society. So, it is a very interesting area. Now, let us get into the area one by one. Now, physics is one which is going to study about the non-living things. Non-living matters and the energy relations will be studied in physics. Generally, all the science really gives about the knowledge of nature, and laws, principle, hypotheses were derived only by the scientific method. But what is the relationship between the science and technology? For example, a science principle can able to help the technologist to frame a gadget. If the gadget is really useful to the mankind, then automatically industries will be developed. See, go to your kitchen, you can see how ordinary grinder, mixie, and so many gadgets available in kitchen. Go to the dining hall, you can see so many gadgets are available. Go to the reception room, you can see TV and other things. So all the technology uses basic science as a principle. Basic science as a principle. Now we are really interested in learning about how the science is related to technology. Science is the study of the natural world via research and experiment. Scientific method is a method by which nature knowledge is derived by science. Technology uses science to create a gadgets useful for the mankind. For example, in olden days, in ancient times, a king want to know how pure is his crown. Archimedes found a principle that proved the purity of the gold in the crown. So, the necessity drives an invention. The invention is guided by science. Archimedes' principle guided the pure density evaluation of the king's crown. So, Archimedes' principle, so it is really used to identify the purity of the crown. Later, it was used for floating laws. Now, ships are floating, films or lines are drawn. There are so many development in the particular law. But the necessity drives the man to go for an innovation. Likewise, a technology can be improved by means of science. For example, mankind want to invent vehicles for their transport. Steam engine is the first innovation. The steam engine is further improved into diesel engine, further improved into electrical engine, further improved into superconducting engines. So, technology can be improved by means of applying the improvements in science. Another thing, scientific improvements can improve the technology also in a parallel manner. For example, transistor devices, semiconductor devices like transistor, integrated circuits, microprocessors can be very, very helpful in developing the computer to the laptop. The transformation of things, the transformation of technological revolutions has really helped us in so many ways. So, science can able to provide the solution for the human problem. Science can able to improve the present technology. Science can help the technologists to innovate new gadgets to serve the human mankind. So, really very, very interesting things. Science not only improves mankind's facilities, it also improves mankind life and life existence. For example, the food intake is converted into energy. Now, man knows how to control the food and reduce the disease so that he can live longer. This is one kind of innovation in the field of man's normal healthy life. So, nature, for the survival, for the safety, for the interest, man applies the scientific method and invents science. Science is nothing but the knowledge and the understanding of man about the nature. Science, if it is properly used, it can be converted into a technology. Technology can help to innovate a gadget that can help the mankind. So, over the centuries, in our kitchen, in our dining hall, in our reception, so many gadgets were coming to place so that man's burden will be reduced much less. Another very, very important thing, the development of a technology can able to guide us to go more studies in the fundamental science. Wireless technology help us to know more about electricity and magnetism in basic science. Likewise, nuclear reactor can help us to know more about the chain reactions. Sometimes what is the perceived thought about the scientist about the atom is now changed drastically into new origins. So, for example, the next agenda. In order to improve the technology, let us study the thermal engine so that you know how the thermal engine efficiency can be improved. Then comes the diesel engine, then comes the electrical engine. So, in order to improve the technology, science is really very useful. Very interesting fact about the science is more non-conventional energy resources, renewable energy resources to protect the nature, to protect the human being, to protect the universe. So many new innovations were really being found rather than digging the biofuel and burning the biofuel and spoiling the atmosphere is gradually going to be reduced, and the universe is going to be cherished with the non-conventional energy resource. It is the innovation of science and integration of technology that is really useful for the mankind. Now, here we are going to list the principles in physics and how it is really being used in the technology. We can able to tabulate so many principles and how the principles are really being converted into technology. And when we know the contributors, science principles, the technology that is really being guided by the science principles were invented by so many countrymen. The universe as a whole consists of so many countrymen, so many scientific findings were found, so many laws were really being compiled. All this contribute to the human's development into this particular universe, particular century. We have reached to a particular level only because of the contribution of scientists, science, technology, and hence we should be indebted to them. Now, let us go to the next part. We learned what is science, what is physics, what is the scope, what is the range, what is the excitement, and how it is really related to technology and how it is useful to the society. We have already seen. Now, let us analyze one important concept in nature and then how physics can be able to get into the content more in-depthly and then classify the things and learn the content thoroughly. Let us see. Generally, usually the objects will be governed by some laws. Every body continues to be in rest or in uniform motion unless otherwise compelled by some external force. The force can be classified into contact forces and non-contact forces first. Force that is applied on the body to change the position. The force that is applied on the body to change the direction of the motion. So, contact forces and non-contact forces are the first classification of the forces. Next comes the force can be further classified as four important categories: gravitation, electromagnetic force, weak interaction forces, strong interaction forces. These forces are really visible in so many domains in the universe. Gravitation and electromagnetism are really visible in macro domain, that is in the astronomical planets and the mesoscopical area. Gravitation and electromagnetic forces are really being visible, but the weak interaction and the strong interaction forces are visible only in micro level. So the four fundamental forces, among the four fundamental forces, the nature of the forces and where the domain it is really being applied, we have really seen. Now let us go into the very important area. Macro domain wherein which the gravitational, magnetic, and electrostatic forces are magnetic, gravitational, electrostatic forces are really called non-contact forces, and the forces are experienced in macro and meso. For example, in the micro forces, inside the atom, there are some forces which are visible. That is called strong nuclear forces and weak nuclear forces. What is the gravitational force? Between the two masses, there exists a force of attraction, which is always proportional to the product of the masses and inversely proportional to the square of the substance, and the force is visible, applicable, operates in all the objects in the universe. But the range of the forces is infinite, but is the weak force 10 power minus 38 times weaker when compared with the strong nuclear force. Whenever we throw a body up, the body experiences the gravitational force and falls towards the Earth center in the projectile part. So gravitational force is the force between the two objects. The range of the force is infinite, but the value of the forces is very low when compared with the strong nuclear forces, but the force is always attractive. But whereas when we go to the electromagnetic forces, there exists a electrostatic force between the two charges which are stationary. The force is charge dependent. The force is dependent upon the nature of the charge. The force may be repulsive or may be attractive, but the range of the force is infinite, but it is 10 power 36 times stronger than the gravitational force, but 10 power minus 2 times less when compared with the strong nuclear force. Next comes the strong nuclear force. Inside the nucleus, inside the 10 power minus 15 meter range, between the nucleon, there exists a strong nuclear force. That is why the density of the nucleus is the highest when compared with all other materials. It is always attractive. There is no repulsive force. It is very strong. It is confined to the nuclear dimensional range. Weak nuclear force is the force that is really exists between the fundamental particle inside the nucleus. It is only because of the interaction of the electrons and neutrinos between the bodies. The range is between the atoms. So the range is within the atom, 10 power minus 13 meter. Weak nuclear forces is inside the atom. Strong nuclear forces is inside the nucleus. Electromagnetic force is in the meso and macro world. And another very important things, the gravitational force exists everywhere. Now, let us compare the dimension. When we take the strong nuclear force as number 1, then electromagnetic force is 10 power minus 2 times less. Weak nuclear force is minus 13 times less. 10 power 39 times less is the gravitational force. When we go to the range, gravitational force and electromagnetic force is having the infinite range, but the weak nuclear range is 10 power minus 13 to 10 power minus 15. This is the comparison between the fundamental forces. So, contact forces, non-contact forces. Non-contact forces can be classified into 4 types: gravitational force, weak nuclear forces, electromagnetic force, strong nuclear forces. So we can analyze the force into so many categories. And not only we analyze the relative strength, relative range, and also the particles which are experiencing the force. Now we are going on to the physical laws and their discovery and their applicability. Newton's gravitational law is a law, very simple law, but it can be applied in all the domains. That is why it is called the universal law. So, a law which is very simple, very useful in all the domain. So physics laws are very simple. Physics equations are very simple, but it is applicable to all the domains. Now let us go into one important property called conservation. Generally, the properties of the matter, any quantity, the property of the quantity may change with the time, but some other quantity, some other property may not change with the time. That particular property is called conservation. For example, let us take the simple pendulum. Let us assume the simple pendulum is in oscillation. In every position, the total energy will remain constant. Potential energy will change, kinetic energy will be changed. Corresponding these two, the total energy will always remains constant. This particular property is called conservation. Very, very important things. Linear momentum is conserved, energy is conserved, angular momentum is conserved. In mechanics, energy is equal to mc square is the mass energy relations. Here in mechanics, for problem solving, we are applying the conservation of energy, linear momentum conservation, angular momentum conservation. We are really applying the fundamental principle to solve lot of mechanics problems. Another very, very important thing. The momentum before impact is equal to the momentum after impact is the conservation of and linear momentum. But already we have learned physics falls under three categories: laws, equation, hypothesis, axioms, and postulates. Conservation is an hypothesis. It is an assumption. Conservation, linear momentum conservation, according to the Newton's third law, can be proved experimentally, but the hypothesis here is conservation is the concept that is really being assumed. Likewise, free fall of gravity, the energy is conserved. So, the conservation of energy, conservation of momentum, conservation of angular momentum, these conservation, a property which is not going to change with the time, is a very, very important in physics to solve so many problems in physics. Theory of relativity. According to the Einstein theory of relativity, the law of conservation of mass, we already seen momentum, linear momentum, angular momentum, energy conservation. Here we are really going to see about the mass conservation. Mass, matter and energy are related by the Einstein mass-energy relations. The atom, total atom is conserved is visible in the chemical reaction. For example, in the chemical reaction, product, reactant. The number of atoms in the product is equal to the number of atoms in the reactant. It is according to the law of conservation of mass in any chemical reactions. When we go to the binding energy, when we calculate the total binding energy, the binding energy is really able to give the explanation for the law of conservation of mass. Another very, very important things, all conservation quantities are not scalar. Some of the quantities may also be vector. It is really applicable in mechanics. So, generally speaking, in motion, in mechanics, linear momentum and angular momentum are conserved, energy is conserved, and in micro level, mass is conserved, which is proved by the energy's mass-energy relationship. And in electrodynamics, charge is conserved. Likewise, so many conservation principles are really available in physics to solve the problems in physics. Also, another very, very important property here is symmetry. Symmetry is another very, very important property. Electron, proton, neutron, neutrino, right-hand rotation, left-hand rotation. There are so many things that are symmetrical in physics. Physics applies the symmetry to solve so many problems. So, physics is the branch of physics that studies the properties of matter, which uses generally the two thrust areas. One is called unification, another one is called reductionism. physics derives the principle, laws, definitions, equations, principles, postulates by means of assuming and approximating. Precise measurement and approximation are the two main guiding force by which physics forms hypotheses, axioms, postulates to derive an equation, to derive a law and principles. So in this, law of conservation, symmetry are very important fact by which physics is really being governed. Thank you.